For each function y equals f of x, sketch the corresponding derivative function y equals f prime of x. So here in the top panel we have the following function. In the bottom panel we're going to sketch out the corresponding derivative function for this function. So let's start by looking at the slope for different parts of this function. So right here, as we're approaching this turning point, this minimum, the slope would be negative, so m is less than 0. Same thing as we're moving right from that maximum towards this minimum, our slope will be negative. As we are moving away from this turning point towards this turning point, the slope would be positive. And same thing over here. This would be a positive slope. At the turning points, so right here, here, and here, the slope will be equal to 0. So when we want to sketch the derivative function, any point where the slope is 0, that's going to become an x-intercept. So right about here, we'll have this x-intercept corresponding to this minimum. Right about here, we'll have another x-intercept that corresponds to this maximum. And then we'll have a third x-intercept right here corresponding to the following minimum. So what we can do here is, so as we are to the left of this x-intercept over here, the slope will be negative, which means that the derivative function will be negative. It's going to be coming up something like this. And then as it is passing this x-intercept, now the slope becomes positive, and it's going to be positive all the way to the next x-intercept. So it's going to be going up and back down like that. And from this x-intercept to the next one, here the slope is negative. So it's going to be going down like that and come back like that. And then finally, on the right-hand side of this x-intercept, now the slope is positive again. So the slope is going to be above the x-axis, like so. If we move over to this graph here, from left to right, we can see that over here, the slope is positive. On this side here, the slope is negative. And then up here, the slope is 0. We have a perfectly horizontal line. Okay. So it means that we're going to this purple part here where the slope is 0. That's going to be on the x-axis. So it's going to look, we'll probably have to use a different color. So from here to here, this here corresponds to the slope of 0. Over here, the slope will be negative. And on the left-hand side here, the slope will be positive. Now note that the three segments here, the three line segments that make up this function here, they are linear functions, which means that when we're drawing, if we're looking at this part here where the slope is positive, it's going to be just a horizontal line, like so, because the slope is constant. Okay. Then as we reach this part here where the slope is 0, it's going to be right here on the x-axis. Oops. I need to, like that. Let's do this again. right? So it's right there. And then as the slope is negative, again, it's a linear function, so it's going to be, oops, that's wrong. It's going to be a horizontal line like that. Now, this endpoint here, we're going to put an open circle. And we're going to put an open circle here. These are holes. The slope is not defined at these corners. These are called corners. And the derivative at corners like this is undefined, which means that there will be no slope. That's why we're not including those points right here. So this would be corresponding to the left corner, and over here this corresponds to the right corner over here.